Hi, this is Mrs. Kidman again, and we are going to be talking about evaluating piecewise functions. Now, if you don't know what a piecewise function is, I would recommend watching the previous video called Introduction to Piecewise Functions to learn what a piecewise function is and how we get it. So here's an example of a piecewise function here. F of x equals x minus 2 if x is less than or equal to 0, or 2x plus 1 if x is greater than 0. Now, we want to look at how to evaluate that function. So evaluate is a fancy way of saying that I want to figure out if I put a number in for x, what the y value is going to be. That's how we evaluate a function. So let's take a look at these two. So look at A. We want to know what happens when we put 0 in for x. Now with these piecewise functions, we have two different equations that we're looking at here. X minus 2 and 2x plus 1. So with our x equals 0, I need to decide which part of this function or which equation does x equals 0 associate with. And the way I'm going to do that is I'm going to look to the left here and check out the parameters on each of those equations. So for this first equation, the only time that this first equation is going to exist is if x is less than or equal to 0. The second equation will exist only when x is greater than 0. So in this first part where I want to evaluate when x equals 0, I need to decide, does it go with the first equation or does it go with the second one? And in this case, because it equals 0, we're going to go with the first one here. So when I'm evaluating that function, just like we would with any other function, I'm going to write that the function at 0, well, I said it would go in that first one, is going to be 0 minus 2. This 0 is going to replace that x up there. So I just put 0 in for x, and that's how I'm going to evaluate that. So if I wanted to solve that more, 0 minus 2, well, that's just negative 2. So what that's telling me is there is a point on this function that's going to be 0, negative 2. Or if I were to look at this function on a graph, if I were to go to x equals 0, I would find the function exists at negative 2. That's as simple as that. Now, with part B, we're going to do the exact same thing, but this time we're looking at when x equals 4. So let's ask ourselves again, does x equal 4 associate with x is less than or equal to 0, option number 1, or does it associate with option number 2 when x is greater than 0? Now 4 is greater than 0, so we're looking at number 2 here. So we want the function when x equals 4. So just like I did before, I'm going to put this 4 in for x in my expression here. So 2 times 4 plus 1. Now I'm going to simplify that. 2 times 4 is 8, plus 1 is 9. So that's telling us that when x equals 4 on this function, y is going to equal 9, or this function is going to include the point 4, 9. Okay, so that's kind of how we evaluate a function. And we're going to do that over and over. So let's look at this next page and practice evaluating the function again. Now remember, first we want to look at which parameter does it match, or which parameter does it belong to. So let's look at this first one. F equals negative 8. Well, negative 8, is that going to be less than negative 2? Is it going to be between negative 2 and 5? Or is it going to be greater than 5? Well, negative 8, that's going to be less than negative 2. So looking here, notice how this expression here doesn't have any x's. That means the our y value has to be a 3. Or this point is going to be negative 8, 3. Because what our function here is going to look like, and this is kind of jumping ahead to a future video, but if we were to look at how this function would look when we graphed it, what it would be is, here we are at negative 2. We would have an open circle because it doesn't have an equal to here. And it would be everything from negative 2 or less equals a 3. So 1, 2, 3, right? That's where that is. Now from negative 2 to 5, it's going to be x plus 2. So I'm going to substitute this lower number in, and I'm going to see that it's going to be here all the way up to 2, 3, 4. It's going to be something like this is what our function is going to look like. And then this last part, when x is greater than 5, it's going to be 2x. So then we're going to have an open dot here and a line that's a little bit steeper that looks like this. So this over here is kind of what our function looks like. So now we want to know what parameter does it belong in, and then substitute for x. If there is an x. In this case, where there wasn't an x, that's just what it equals. So looking at number 2 here, -2, now that's going to belong in our second equation here. So I'm going to do f of -2 is going to equal, substitute -2 for our x, plus 2, -2 plus 2 equals 0. Okay, so that's what it would evaluate to, is it equals 0. When x equals 0, it's also going to go into this second expression here. So we would do the exact same thing. F of 0 equals 0 plus 2, and 0 plus 2 is 2. Now check this out here on our graph. We can kind of see that our line goes through right there too, right? So we know that the point 0, 2 is going to exist. Now this is a rough drawing, so it doesn't go through exactly, but that graph, we can see each of these points will exist there. Just like we can see -2, 0 exists on our graph right here. So f of 3, that's also going to go into our second expression here. So we're going to do that again. F of 3 equals 3 plus 2, and that equals 5. Again, you can see that that's how it would work. Let's skip 5 and go to 6. F of 10, well, f of 10 is going to go with our last expression here, and we would do 2 times 10, and 2 times 10 is 20. So in a nutshell, how you evaluate a function is first, you ask yourself, which parameter does the x belong to? So does it belong to less than -2, between -2 and -2 and 5, or greater than 5? And then after you decide which one it belongs with, you're going to substitute whatever your x value is for the x in the expression associated with that parameter. And that's how you evaluate a function.